today is likely going to be another kind of confused session. There are very many things that we should start saying. Now, with this very small cohort, again, we'll make it interactive as possible. But there are a few core ideas that I think it's so good to communicate. So, we start from building information modeling. We've seen yesterday how different types of IT systems come with potential features as a function of the semantic understanding of the system. Today we'll look at recent developments in building information modeling packages, so what they are, what they provide, and we'll start looking into the problems that this brings to the industry. Because the benefits are really straightforward. It's very simple for us to say what are the benefits of BIM. So what are the advantages that current practices can easily get from BIM. And I think in large, these benefits have already been materialized. So people that are adopting BIM today already have significant benefits in their workforce and in their workflow. Sorry. But the industry is now facing a lot of challenges when it comes to going beyond the easily achievable set of benefits. So to go a step forward, a step further, big changes need to happen across the industry. And the main problem there is on collaboration. So if you use a tool on your own, you can probably bring it to the limit and take the maximum benefits for your own firm. The next big thing is to be able to agree with other people on pattern and workflows to materialize those benefits in a broader community and in a broader environment. So, in light of what we have seen yesterday, so considering the semantic value of building information modeling, what do you think is the ethos of working under a building information modeling environment? We can kind of easily classify it with a statement. We say that the building information model, what it is a system that can serve as information resource about a facility, any sort of facility, any sort of physical facility. But interesting bits come in when you say, well, what does it do then? It provides a reliable basis for decisions during its life cycle from inception onwards. And this now makes things a lot much more complicated, because we are already extending the time frame of usage of a building information model from the very moment where you started thinking about a new build to the time where you demolish it. So, we currently have softwares that are sold as BIM tools. Which software, or so how can we, what are the software at large that we can consider to be BIM tools? Let's start with a bit of interaction, and tell me what are the bits of software that you know of that you think are BIM tools.
Revit.
Okay, the obvious, of course, would be Revit, ArchiCAD, Aviva. Aviva what?
It's the petrochemical modeling sim where
Okay.
basically it's component modeling.
Yeah, I'm not sure it's really. So we call it with its first name. Aviva is the last name, right? The first name is PDMS.
Right. Yeah.
Plant Design Management System.
Tekla.
Right, good. Tekla.
Bentley.
this is
But
becoming
isn't Navisworks extra?
Navisworks.
That's an extension of what it is, isn't it?
Let's say just Navisworks, so we're talking about something we all know.
IFC.
These are applications, these are softwares, right? IFC is not an application. It's a file format. We'll talk about it extensively.
Well, I would say Kobe, but that's a format as well. Isn't
Again,
it really?
yeah. So we can start thinking a session about that. So we can start thinking about standards.
Here's a talking about software again, XBIM toolkits.
Again, yeah, this is a software. Interesting.
3D Studio could be a software for it.
I know MicroStation is an extension of Bentley, but for that,
It's all right. We can call. We can say that there are other in
Yeah.
this category. I think, right?
there's a new one coming out, which is the VIO, which is produced by M6, and that's conceptual phase anyway. So
No. That's
Yeah.
what I want to get to.
all right,
I exactly want to get to the fact that all of these tools that you've mentioned, most of them, can only help us in one particular stage.
no, VIO is actually software. It's cloud-based software in its conception phase, so it hasn't come to market yet.
Yeah, sorry. I was talking about the conceptual phase of a building.
Right. Whereas, because there's theories behind it trying to extend it through the concept, but never mind. Yeah.
So, all of these tools here, Revit, ArchiCAD, PDMS, Tekla, Bentley, and so on, they are design environments. You use them when you want to design a building. But with that definition, so if we do accept that definition, the lifetime of a building, well, it can vary a lot, but it's generally greater than 30 years, let's say. So you hardly think of a building that is to live shorter than that. It's not frequent. It can happen, but it's not frequent. You have temporary pavilions, you have all sorts of stuff, and you have things that you build up and then you realize they were seriously wrong in their conceptual integrity, so you probably demolish them much earlier than you would want to. We've seen now in the center of the city the demolition of buildings that were probably, just judging from their design, were probably built in the 60s, I would say. So we're talking about 40, 50 years minimum for a lifespan. So what does this stage last? Well, you have inception, you have a bit of conceptual design, you have the proper design, you have construction, and you have the operational life of the building. And all of these things really cover design. And this will probably last, depending on the complexity, 6 to 18 months of work, something like that. Make sense? Of course, these are all random numbers. There is no. Give you a ballpark figure of what all of these cover. So we're covering 18 months. Now, interesting, Navisworks. Are you familiar with Navisworks? No. So Navisworks is a software application that allows you to bring together, well, it does a number of things, but one of the things it does is to bring together in one visual environment multiple formats for a model. So you can bring together a piece of software from Revit, a piece of information from Revit, a piece of information from ArchiCAD, another piece from Tekla, and you see them in one cohesive experience. So it's a multi-format reader. On top of that, they have extended it so that it's not limited just to physical 3D models. It does read into meta information, so properties of the components that you select, but also can tie into different types of data. You can, for instance, connect to planning information. So you can say, well, this element here is going to be built during those days or during this activity, and this element here is going to be built at a later stage. So you can have a view of how the building is going to be erected element by element, and that's called 4D construction. So 4D being 3D plus time, all right? 3D being X, Y, Z, of course. So we have three-dimensional geometries and time on top of that. This is not the only application that does that. It's just one of them, all right? So this one is bringing together information from multiple sources, including 3D and others. So you have time, you might have cost, you might have coordination information, so you can use it to see that there is no clashes between the elements from multiple sources. So you put together a model that comes from your architect and a model that comes from your structural engineer, and you see, well, are the columns all aligned? Are we talking about the same columns? Is a column missing? Or is there a piping infrastructure of some sort? So is there an air duct going through any of the columns in my building? So do we have any clashes, any physical clashes between the elements of my construction? So this is also important, and this probably happens during the construction stage. So you want to do that before or during the construction stage of a building. So this is probably another, depending on your budgets and ambitions, another 18 months. So we've covered more or less 3 years of time during the life cycle of a building. All the rest you haven't mentioned. You haven't mentioned anything else that goes beyond this. I was asking, sorry, before you came in, what are the software tools that you know are connected to building information? And this is the list that came up from. So, if we do accept this definition of building information modeling, and this is 3 years over 30 years of lifespan minimum, we can say that what we know of building information modeling covers roughly 10% of the lifetime of a building. Is that enough? No. Clearly not. So, today we'll try and start thinking about what we can achieve with BIM. Before I can kind of tailor the lecture to your needs, before I can start doing the lecture, I need to kind of gather what is your understanding of building information modeling. So I'll ask you a couple of questions now. And we'll start specifically with this aspect here, so the design aspect. Tools that we use to produce a design. How many of you have ever used any building information modeling design environment? Was that Kieran? You haven't? No. Okay, that complicates things.
I'm fine with them from a fundamental level.
Say again?
I'm alright with them from a fundamental level. Fine with that.
Alright. So we'll quickly try to understand what a building information modeling design environment is. Can I ask you your background? What's your background?
Civil.
Say again?
Civil.
Civil engineering. Okay, so you've... Okay. What type of design environment have you ever used?
Just AutoCAD.
AutoCAD. Okay, so vector elements, just lines, patterns, arches, curves, circles, and everything. So you would be building up from nothing the representation of a building. So it will be or maybe of a civil environment, so roads or a dam or something like that. Okay. So you will start thinking, okay, I have a blank sheet of paper, and I will start putting lines on it. And at some point, this line will make a meaningful presentation of an idea of a project that I have. And I know that this line will be the edge of a road, and this other line will be the middle of the road, and this other line will be a pipe running under the road that conveys whatever water or waste or whatever. Now, when it comes to building information modeling, the idea is similar. This is what you need to deliver. You still need to deliver a drawing that people can understand, that conveys the idea of the structure. But the benefit that you have, let's see if I do have in slides about that. Sorry, I had an eraser, didn't I? I used it. I used it, there.
You had a piece of piece of blue.
Lost it. I'll get another one.
Right, you need just 3 minutes. So what do you have with that? 4D with time, 5D with cost?
Yeah, 6 days facility management.
6D facilities management.
Yeah.
I don't know if I should know it because we are not touched it.
I'm familiar with it, that's why this was another prior coming on the course, and I knew it would be important.
Yeah.
Yeah, every BIM presentation always has the levels of BIM and
The start with the
Ds,
Ds,
yeah.
and go for
The levels of BIM is different. It's level 0, 1, 2, 3, but shared value will cover it.
We'll cover lots of things. Yes, that includes. So, now again, the aim is the same: is to convey to everybody else in the construction process information about the building. But on top of that, we want the computer to be able to understand that same information. So we are not telling the computer that there are lines. We're telling the computer that there are elements that have some that convey the essence of them being building parts. Physical or non-physical, it doesn't matter, they can be both, but they are all semantically connected to some idea of a building. So in a BIM model, when you have a set of tools, and you will not have tools to create a line or a circle or an arc. Instead, you'll have tools to create a wall or a window or a door or a slab or whatever other physical element of the building that is available to the tool. So you select this first and say, I'm drawing a wall. As a result of that action, the system will tell you, okay, do you want to draw a linear wall or a curved wall or a round wall or of any sort, okay? And you will then, of course, go on clicking around in a vector space, in a Cartesian space, to define the geometry of that element. So you could start clicking here, there, and there. And what you get is not two lines. What you get is an idea of a wall that starts from some point, extends in some direction, and then turns 90 degrees and goes on. All right? The major difference with this is that the system will start putting in lots of information about that. By default, it will say, okay, this is a wall. It's been drawn on level 3 of our building. So there will be somewhere on your, in the rest of the information, the idea that you have 3 levels. That they are, the level 1 is 4 meters high, and the second one is 3 meters high, and the third one is 3.5 meters high, and then we have a roof. Okay? So all of these will be stored somewhere else. So as you start drawing this, the system knows that this is happening on level. Well, you have told the system this is happening on one of the levels, so we'll say, okay, if it is on level 1, then this is a 4 meters high. I need to stop moving as I go. So this is 4 meters high, and it will know this already. If you go and change this, the system might or might not, as a function of what you set up, update all the walls on level 1 and make them consistent with the new specification. So you could actually go and say, okay, I changed the height of that building, and all of the walls will automatically be reflected, because the system has the understanding that that is a wall, and walls are generally attached from one floor to the next. Of course, this might not be the case for some walls. You might have somewhere a small wall that is just a divider of the space. So you might have at some point this idea of a little wall that kind of opens the connection visually between two spaces, and you have the school office on one end and you students on the other. Now, if you change the height of that story, of that level, you don't want that to change. You want that to stay 1 meter high. So, of course, the complexity of this is that the system must have ways in its database structure, in the way in which it saves the data, and this goes back to what we saw yesterday about the importance of how we store information on data, must have some sort of bit, flag, information that tells it, look, this wall is a wall that is somehow different from all the others. These are two walls that are connected from ground to ceiling. This is instead a fixed high wall. All right? So, this is just to give you an example of one possible type of information that the system must be aware, must be capable of dealing with if you want flexibility, so the power to update things automatically, but customizability, is that right? Yeah. Customizability. So the ability to specify that these things this automatic behavior should not happen on some of the items. Okay? So all of these abilities to change something as a result of your action, or don't change something as a result of your actions, must have been thought by the programmer of the building information modeling software that you're using. Okay? Computers, in their own essence, know nothing about building. They can only know that some things should happen if the programmer has put in code to deal with that. And if the data structure contains appropriate information for them to make a decision whether some automatic change should or should not happen. Okay? That's one of the benefits of a building information modeling aware design environment. Lots of automation can be conceived. So in this sense, creating a building information model is much different from making a drawing of a building. It is about giving an information system the idea of the properties of elements inside a building. Okay? On top of this information and data layer, intelligence can happen. Algorithms can be run. automation can be implemented. Okay? Is this a clear understanding for everybody? So to create this, a modeler, so the person that is designing something, uses intelligent objects. Intelligent objects, meaning that the wall will be behaving differently from a window. And intelligence here being the ability of the wall, for instance, to snap to the level that you specified. So to the idea that there are, well, if you look at it in a section, there is a ground level, so there is a level where your ground is, and there is a level where floor 1 is, floor 2 is, floor 3, and then you have a roof. Okay, so if the system does have the idea of a wall, but it does not have the idea of stories, this level of automation cannot be possible. Okay? So the semantic properties of a building are elaborated for you by a system that knows about different classes of elements. A class being a collective that shares the same properties. So a class is the idea of elevations for some elements. Another class is all the vertical elements that are structural, right? Another class might be all the vertical elements that are not structural. So I could have a wall that is not as doesn't come with the ability to support any weight. Because it's not just about the shape of the building, it's about its integrity as well. It's about the fact that it will work as a machine. Buildings are also machines. They are there to serve functions. They are there to serve you with heating and ventilation and lighting and structural integrity, and they have to be resilient. They have to support earthquakes. They have to make sure that water does not come in if it rains. They have to support the load of the weight of the snow when it comes, and so on and so forth. So some of these evaluations can be left to the user. So you're drawing something and the building information modeling tool cannot help you dealing with that. But there are situations where the building information modeling tool can indeed help you with that. So if you say, okay, this is my building, I have 4 walls, and you go in and say, okay, now I put the slab on, and I put an elephant on it. Now I wish I could be able to draw an elephant. It's going to be something like this. It's going to be having big ears. It's going to be having, how do you call that?
Trunk.
A trunk. And this is mammoth, really, so it also has teeth and then the 4 legs, and there you go. So this is our elephant with happy eyes. Now, as soon as you start putting the concept of an elephant on top of a building, the system might be able to tell you, look, these walls are going to collapse. They're going to collapse because maybe not the walls, but maybe the beams that go across here, they're not strong enough to support the elephant. How can it do that? Yeah.
You can put in tolerances and put in
Before you have tolerances, you have to have go specific, yes. You can be more specific. I mean, for this very specific case.
You can apply protocols and rules and conventions.
You're still generic. Be specific. What does it need to know to be able to tell you that the elephant will fall down in the swimming pool that you have on the ground level?
The strength of the wall.
Strength of the wall. And what else?
Material?
Maybe, but the strength is enough if you want to calculate the stress. What else? It's basic, it's elementary.
Yeah. The weight of the
Yes. How heavy is an elephant? So, do building information models know about elephants? I don't think so. But they will likely have the concept of load and weight of elements. And they will have at some point to save this information into a file that you can open the day after and recover all of this information and be able to know that the elephant will have 4 legs. So the footprint of the weight of the elephant will all be conveyed to the rest of the structure through the surface of the 4 feet. Can you see this? Can you see how rapidly the amount of information that you need to be able to deal with, to be able to provide some extended features over just the basic visualization of an element, becomes increasingly complicated, right? Because it's not good for us to know that the elephant has a weight, and that's not enough, because the weight, I mean, the elephant might be there, but it might be actually hanging from the ceiling, and the ceiling might be very robust. Make sense? So, we have seen that it's possible for us to think of file formats to store this information. Every time we have a problem, how do we store a color, how do we store a line, but it also comes with limitations. We've seen how the limitations are connected to the way in which you save a number, how big it is, how precise it is, and so is embedded in the nature of the encoding and of the data. Okay? So, for this reason, building information modeling has been with us for very many years. I remember I was still a kid. I was still a kid when I went to my first fair, where I saw the ArchiCAD, probably 1.0. It was a beautiful building information modeling environment.
Age 7 was that?
I don't want to say the year.
I'm sure it was age 7.
I don't want to say. It was a long time ago. So it was a beautiful design environment where you could save lots of time, and I was used to AutoCAD back then. I was working with AutoCAD. Yeah, you are all familiar with AutoCAD. You know you can draw lines, and sometimes it's you know it could be very efficient if you are used to drawing with your pen and pencil. But so when we saw that it was possible for us with just 4 points to define a room, we saw, wow, amazing, and automatically the system will tell you, okay, this is this much height, there is a roof there, and so on. And you can put in a window just by clicking a window and dragging it over. And all of the details of the window will be put in for you automatically. And then you say, beautiful, now my wall is like that, it's curved. And the system will tell you, no, unfortunately, we cannot deal with curved walls. We can only deal with straight walls. My house is not like that. My house has a curved wall, because physically we can do a curved wall with no problems. So, limitations in the underlying abilities of the software would make it impossible for you to design what you wanted and take the benefits of the automation. Okay? Now, nowadays, you can, with current building information modeling application, you can design any curved walls you can think. You can cut them vertically. So in section, they are curved in plan, and in section, you can say, well, they actually are not all the same height, but they go and are cut on a profile like that. So you can actually design any kind of funny geometry that you want in 3D, in 4D, whatever it is. So a lot of time some time has gone by the time that you had such a big limitation on design environment. But big limitations are still there, because limitations are intrinsic in the nature of what the software designer has considered to be useful information about such an element. Okay? Okay, I want to go back a bit, and I'll probably unwillingly move to the next slide. So we have seen that to create a BIM is to use intelligent elements in an environment where other elements are also intelligent. This brings us to the idea of a library. What's a library? A library is a set of properties that one of such elements has that you can exchange from one environment to the other. So a library could be a list of possible wall types. We make all examples with walls, but this, of course, is valid for all other elements. Okay. So wall types. What's a wall type? Well, a wall type is a set of properties that a number of walls share. Can you think of a wall of structural bricks, structural blocks? Of course you can. So you can have the idea of a structural wall, and then you can have the idea of just a non-structural wall. Okay, so a wall, a stud wall maybe, a wall that you build with vertical timber elements, and then some sort of what's it called, this thing?
Gypsum boards.
Some boards, yeah.
Boards.
Gypsum.
Gypsum part. The plasterboard.
Plasterboard, yeah, that's the word I want.
Gypsum's a trainer.
Yeah.
So, plasterboard on top of it. Okay, so these can be part of a library of elements that is kind of previously standardized inside your design environment. So you 1, 2, 3, 4 clicks, and then you say all of these are structural walls. And then you draw 1, 2 clicks, and you say, well, this is actually a non-structural plasterboard wall. And the system knows how to design a structural wall, and knows how to design, but how to represent, to show graphically the qualities of this type of wall, knows how thick it is, knows something about its mass, knows something about its structural strength, and so on. When it comes to the stud wall, it might actually have to ask you more parameters. So how far apart are all of the timber elements? Again, these are all of this information that the building information model cannot ask you just by asking, Kieran, can you remember how big that measure was? So that's not the level of interaction that you have with the software. Somebody must have at some point designed a user interface, a graphical user interface, that is asking you about that specific dimension. So center to center spacing of all the vertical timber studs. That can change. You can actually set it to 400 or 600 or so, right? And is that important?
Yes.
Why is that important?
Because of the data that can be extracted from it for the construction phase as well as design.
Exactly.
Planning.
So you're not just interested in how this space come on, how I have two big shoulders, I can control them. Yeah, such a strong man. So it's not just important to know how the building will look like. Okay, we want to reuse this information for all possible purposes. So counting how many timber elements we need is an important factor for ordering them and having them on site when we need them. And also, that could help us understand what the weight is of this element for structural evaluation purposes. And that information can also be useful for us to determine the cost of the build, because each of them will have some cost. All right? So, what are the purposes that you can think of for a building information model.
Efficiency of the.
No, I go down and be very specific. We already said you can visualize. Now, whether you are English or American, you will swap this for an S or a Z. We'll adopt a random approach here. So whatever comes to my hand, I'll write. To visualize a building. What else?
Think about the work, construction workflow.
Okay, we call that 4D.
Yeah.
3D
5D,
plus
6D.
time, okay? So 4D is time. So construction sequences. What do we do first? What do we do next?
Evaluate the cost.
Cost. Now, luckily, we call that 5D.
You can think beyond the construction process.
Yes.
And call it 6D.
Now, I call them 4D and 5D because there is broad consensus in the industry on this. So, lots of people think of 4D as time, and lots of people think of 5D as cost. Not everybody, but lots of people, the majority. 6D, everybody calls 6D something different. So that's why I'm not writing down 6D. But you're right. You can look at, say again?
It's facilities management.
Facility management. FM. What is FM?
It's basically after construction, it's the handover between that, and it shows you all the data sets, like all the construction details and technical drawings. Not just construction, but with so with ventilation and everything. So it's providing for the lifespan of the building. So after the 3 years.
Facility management is providing operational information for the regular and so planned and unplanned maintenance of a building facility. Okay? But it goes beyond. It could be going beyond that. It could be facility management could be the determination of how well you're using your building. What is the proportion of the space that you're actually using? Do you have any free room on that day for a new class? Do you have any maintenance that you have to run on the specific windows of all the south-facing facades of your estate? So you can think big. You can think that you are owning a large estate. If you are a university, for instance, you have multiple buildings. And facility management is the ability to query your vast database of elements and spaces to make the best possible use of them. Okay? So we have used a very broad kind of thing, but definition of facility management. There are multiple sub-definitions that we could have used, but it doesn't matter. We're just thinking about that. What else could we do?
Well, with regards to that, it assists in planning, so you derive technical information. I don't know how you
Say again, sorry, planning?
Planning, so it derive technical information from it. But that's visualization as well, I suppose. But you also schedule it as well.
Can you think of automated building regulation compliance?
Yes, instead.
So this is trying to automate the process of making sure that whatever you design is suitable to the laws and legislation and the building regulations that exist where you are planning to build your building. So in Italy we have tight regulations when it comes to proportions of windows and floor area. So the windows must be bigger than 1/6 of the floor area, and there will be no point in the room that is at a greater distance of 8 meters from the window. So if you have such a simple scenario, you can use an automated algorithm to inquiry the shape of the, and therefore the area of the floor. You can inquire the area of the surface, and you can say, well, is the proportion respected? That's an easy check. So, as you are drawing your building, you will say, well, I'm building this building in Italy. Is the Italian building regulation framework respected in this drawing? If not, the room could go red, could highlight that there is a problem there for you, right? So, automated building regulation compliance. Can you think beyond that? So this is in some way replacing the care of the designer in knowing the environment that it's supposed to be working in. Make sense? Mm-hmm. Can you think of going beyond that as well?
Safety?
Just keep it in this region of compliance.
Building regulation.
I mean, once you are sure that your things are compliant,
You can exceed.
what do you do? Okay.
In terms of it depends.
True,
on
true,
what
yeah.
you are.
What do you do? What as a professional? What is your next activity? You go to the council and you submit the drawings,
Yeah.
and the council comes back to you and says, okay, they are okay or they are not okay. They give you consent
And approve the
or
document.
approval to build. Can you think of automating that? Can you think of a big red button on the bottom of your drawing where you can say submit to the council? Okay, you can think, I'll press that, and in 3 weeks' time somebody will come to me and tell me whether it was approved or not. Okay? But you can think beyond that. You can think that when you press submit, this will be sent to a computer system in the council. Some automated process there will evaluate whether it is fully compliant with all the regulations of that place and give you back a certificate in real time. So you press the button and you go, ta-da! Okay, you can build in real time. Or you press the button and you get a big red cross. Sorry, this drawing does not comply to our regulations. Please amend such and such. Thank you very much.
Ah, yes, we do something like that.
Say again?
Ah, yes, there's something like that, but it's not what this
Well,
is.
it's not connected. No, it's
No.
it's not connected to the council. No, at all.
Pass building regs.
You can test.
Yeah.
So it does this bit here. It does some sort of checking for building regulations, but it doesn't automate the process of sending the paperwork, receiving the formal response. But that's not impossible. It's just not there, unfortunately, yet. So you'll still have to print out the documents and go there and say, "Good morning, my friends."
No,
And
it's cool. No, like that.
in some countries, you'll have probably to bribe a bit. I mean, I know, I come from Italy, but can you think of a button to automate bribing processes? Yes. Bribe enough. Okay. No, I'm kidding, of course. That never happens in construction.
No.
Never. Why would it ever happen? It doesn't.
Right next to the price fix button.
Yeah. Okay. Can you think of more functions?
You mentioned before clash detection.
Clash detection. That's current. Yes. Clash detection. Clash detection. What is clash detection? Do you know? Okay. Clash detection is the automated check that a software can run whether multiple components are overlapping each other. So you have, say, a heating duct that goes through a structural element. Okay, so you have an air duct that is drawn going across that beam. The system knows about the three-dimensional geometry of the duct because you have designed it, and it knows about the three-dimensional geometry of the beam, so it says, look, you didn't realize that there was this physical impossibility in the construction. We call them hard clashes. So clash detection can be happening on hard clashes. Of course, there is a second category that you can, I think, guess. The second category. So we have clash detection, and that happens in two ways. One is called hard clashes. Guess. Oh, you see, I know you. We had brilliant students. Soft clashes. What's a soft clash? Now we're starting to challenge our BIM professionals here. Soft clash is not exactly. That starts looking to beyond the physical geometry of an element and look into the into the incompatibility of geometries. So maybe you have a pipe that is running next to a beam, but it has been designed to be too close to the beam, so that it's impossible maybe to install it, because you can't. The spanner will not fit to kind of do something about it. Okay, or maybe the pipe generates too much heat, so that it's incompatible with the fire regulation about structural steel elements. So it overheats the steel. You don't want that, because overheated steel becomes weaker. Okay, so that's a soft clash. So it's a clash that goes beyond the mere the simple physical impossibility of building something. Okay. Now more functions. There's plenty.
Collaboration.
Right. Collaboration.
Customization.
Collaboration. What's it all about?
You can have multiple disciplines working on the same model. You can have multiple people working on the same file at once using a central model.
True. Yes.
Getting people together in one single room.
But what's the problem with that? We can share files, right?
Yeah.
I work my file. When I'm happy, I give it to you. You give it back to me.
You can work on it in
You can work collaboratively.
Yeah.
And the problem with that is associated with the current pattern in the traditional workflow. Traditionally, I would come to some stage, send you a drawing, and you would take your time to look into that, evaluate it, give me some information back. Now everything can happen in real time, because as soon as I press save, you could be automatically updated. And again, I'm feeling very old today, but I remember distinctly a time in my early years when we were drawing on something, and the next step for us would be to print it out on a plotter, fold it properly as the ISO standard demands, put it into a box, call a person that would come to our office with one of those mopads, yeah, and run across town and deliver that to a structural engineer.
Still happens, you know.
I know, but that's stupid. It shouldn't happen. And the problem with that is that the legislative, okay, so
We had it right.
legislative framework still requires at times that there is a printed copy of a drawing, so that official statements can be made about that, that formally that's what you received. Okay, so why is that? Well, because everybody can agree that if they have a piece of paper in front of them, that's what it is. There are still plenty of things that you can say that about understanding it, but there are little doubts about how people should read it. There are standards to do that. Now, in my experience, that does not hold for information technology, not even AutoCAD drawing. And I'll tell you a nice tale about this. Some years ago, people were working, my acquaintances, because I wouldn't go that far, were using AutoCAD to work on some files. And they were drawing them and they were saving them in DWG format. You're all aware of that. You know what it is. Now, these guys were lazy and they had a really bad filing system. So, they gave random, we're talking about students here, they were giving random names to the file that they were working with. But they thought they could cope with that because they had another piece of software called, I can't remember now, it's long dead, that software. It was something called QuickCAD or something like that. QuickCAD. And what QuickCAD did was to give you a quick view of the content of an AutoCAD file. So you would just go through your folders and immediately you would see the content without needing to open it with AutoCAD and so on. So it would hold a snapshot. Now, these guys, after some time, well, what happened at the university is that we moved from one version of AutoCAD to the next. So the file format changed. And these guys didn't realize that QuickCAD would not be able to read everything properly in the new format. But it would still show something. So they started thinking, oh my goodness, what happened to my files? They are all ruined. They are all ruined. They were going to give an exam in a couple of days' time. I did architecture, by the way. I studied architecture. So these were my fellow architects, well, students. And 3 days from the exam, they thought, I have lost everything I've designed this far. So I've lost 6 months of work. They didn't realize it was a problem with the file format and QuickCAD not being able to read the new information stored in there. So they panicked, they went to the professor and asked if they could submit the work 6 months down the line, because that was the next available slot. And that's what they did. So they've lost 6 months of their academic career because of a file format incompatibility issue.
Did they not go in and check the actual files? Because that would be the
I mean, we're talking students here. You know how students stupid are, right?
I don't
Oops.
know.
Oops.
I
They
could be
didn't.
disputed.
No, I mean, trust me, this is a sad but true story. So, the reason I'm bringing this up, it is because QuickCAD was a really bad piece of software. But problems and bugs and misfunctioning of software is not limited to really bad pieces of software. So that's why the legislative framework still demands, in some situation, hard copies, because they want to be sure of what is formally there. So there is an issue when it comes to collaboration of interoperability. Interoperability is a fancy word that goes towards making sure that you can both interoperate, so that multiple parties can operate interactively on files. We'll have a look tomorrow at file formats that allow for interoperability. Okay? So yes, collaboration. We only have 10 minutes, I suppose, but and I am at slide 3 of 29, I think. So I guess we'll have to go on later this afternoon. But we had already a session plan, so I was hoping to make it more interactive, but it's still going to be probably kind of scattered. Collaboration. Anything else?
Customization.
True. Customization. And that comes down to,
Software as well as components within it.
yeah. Can you go beyond that?
Yeah.
Now think beyond the design stage. Beyond the design stage.
Yeah. You can,
Okay. What do you get beyond the design stage?
i.e.
The construction stage.
Yeah.
What can you do during the construction stage?
What can you do during the construction stage? Like, work method statements and everything like that.
Yes.
Apply technical.
Health and safety compliance.
That's the one.
What's next?
Construction, buildability, report plating.
Buildability. It was kind of there. I mean, we had
Yeah.
some sort of
Physical.
kind of model checking. Okay.
Yeah.
Clashing and so. So buildability. It is kind of embedded there. But buildability is also something that you do during the design stage. I think. Take construction.
Sustainability.
Yeah. But that's
Again, that's design, right?
Yeah.
There are operational aspects of that, but
Sorry, the
think
Conservation,
of
yeah.
people bringing things to site and putting them up.
commission.
Measurement, yes. So progress, check. You can actually check that what you have built is matches with the virtual model that you have. So you can, how can you do that? You have 3D laser scanners.
You can have augmented reality as well.
Yeah.
So
So you can go onto site, put a machine down that will measure a lot of elements in the building and then compare their position against the theoretical position that they should have, so that you know that whether you're progressing correctly. You can integrate that with your 4D and check whether they are on target. So you are at the point where you were supposed to be by then. On target meaning on time. Okay. What else?
you can use augmented reality, but that's similar to 3D.
Yeah, it's connected to this. It's checking the augmented reality is just another way of having a visual feedback, mixing real visual data from the site and model information. What else?
Commissioning as well.
Before that.
Before that, setting out engineers setting out on site, but that's okay.
Right.
What do you bring to site?
Materials.
Materials.
Storage.
What type of materials do we bring?
Building material.
Of course. Oh, damn it. I thought it was electronics.
Where?
We
Very
build
many types. You can
many types. Can we try and classify them?
see. Yes, there's a
Steel.
We have,
structural.
okay, we have raw materials. Okay, we have concrete, we have timber, we have all sorts of stuff. But sometimes we have manufactured materials. So we can automate the supply chain automation. So we can add somebody that, some sort of automation on ordering these materials in so that they are delivered to our site on the right day. We can check if we put some particular tags on these elements, we can maybe scan them optically when they reach site, so we know that all the elements are there and where are they stored, so that we can pick them up. Can you think beyond that?
Yes.
Before a material can be brought to site, before some window can be brought to site, what must happen?
The test of the materials.
Before you can test it, you have to fabricate it. Fabrication. So, you have a model of a window. Why would you need to pick up the phone and call with somebody and tell them, look, I need a window Oh, well, sir, how big your window needs to be? Oh, it's 22 inches tall and 25 inches wide, and it is the type of glass we want, and this is... Okay, thank you very much. We'll come back to you with a quotation in a couple of days. No, we don't want that. We want a button on our interface of design that goes bang through our providers, and they will come back to you with a quotation in real time. And on top of that, they will tell you that they can deliver to your site on that day, and they will automate the construction of that. Because to make a window, what do? You will buy a linear profile, aluminium, timber, whatever it is. You cut it to measure, you cut an angle into that, then you put another one next to it, and you put some sort of glue and stuff, and then you have sealant and everything. And nowadays, you might be shocked to know, lots of the things are done by robots. So or machines anyway, right? We call them robots, we call them machines, doesn't make a difference. It's computer-aided manufacturing. So you can think that you have a big button on your screen that, bang, builds the element for you. What type of information do you need to have for this?
The size, weight.
Size, weight, material specification, tolerances, and I wanted to come to tolerances because you've mentioned them a number of times now. So
the essential.
they're essential, tolerances.
The technologies that like run.
So if it is too big or too small, it won't fit. So you have to exchange not only the general specification, but also tolerances, acceptancy, and so on and so forth.
Saturation, stuff like that.
Color, all sorts. So the amount of information that you need to exchange becomes immense. I have 2 minutes, and I haven't moved my slide yet. Still,
You've done it plenty of times, honestly. It's just you haven't noticed. We all know the slide.
Okay. So how can we explain that this huge amount of information can be now happen just by clicking on 3 points? So because that's where we started from. Remember, we started saying, well, we have a building information model. We have a building information modeling design tool. We picked a wall. We picked from a specific type of wall, so say structural wall. And then we said 1, 2, 3, bam, finished. Now, of course, we are relying on intelligent elements, and we are relying on the fact that lots of these constraints, lots of the properties that are automatically added by the system are chosen by default. So by default, the wall will attach itself to the story below and the story above. Sometimes yes, sometimes don't. But I'm just saying, one software will do it in one way, another software will do it in a different way. It's arbitrary, right? Now, the kind of way in which this curve happens is also defined in the library. Okay? Say this type of connection here might be asymmetric. You might be a wall that goes straight to the end and another one starts from there, or you could have a way, you can have it the other way, and these might be done of 3 layers. This wall might be a layer of, a layer, layer is probably not the right word, but like a...
No, it's a layer.
It is a layer.
Yeah, brick.
Yeah, a layer of brick,
Cavity.
a layer, a cavity of some sort, some insulation of some sort, and then another type of material. Now,
or a skin.
what happens in this thing here is just selected by default from the application as you start clicking 1, 2, 3. So there is a major risk in all of this that some of these decisions that appear to be completed and finalized as you put in 1, 2, 3 clicks have not really been thought through carefully. And this brings us to the important fact of the LOD, level of detail, which means how much do we really know about this wall? What are the properties that appear to be visible inside the building information modeling that have been completely thought through, and which ones haven't? There is a big issue here of validation. This only applies if you are working in a collaborative environment. Because if it's only you working on a design, you know what you like and what you don't like, or what you've done this far. But when you're starting to send out a drawing, you might sending out lots of information like that without even realizing that that is being specified by default from the design environment for you. Okay? So this is one of the problems that we'll have to deal with. In the next sessions, we'll try and expand on how to achieve that. Okay? I would love to give you the time to ask questions, but that's going to happen in another session.